Thanks. So, we have the pleasure to talk today about CSIN, or a little bit a longer title, using SBOMs and Cilium in legacy and cloud-native applications to trace down vulnerabilities. So actually, what is this topic about? Now, I know it's nearly the last slot, but at least you have a little task from me to do. Just think of any web application you might know, or you own, or yeah, you know the architecture about, and just try to count the dependencies you have in these applications. Okay, just think of a web application and how many dependencies do you have in this application. So, if you got your application, now we go one step further, including the legacy parts, because we all have some legacy parts in our software architecture, in our infrastructure, which are not running cloud natively. I know we are here in the cloud native days, and we all have our cloud workloads, but to be honest, we all have our legacy parts in the basement somewhere. So, if you have your rough number, just estimate it, what dependencies are on the execution path of a web request. So if you have your architecture and you're getting a request to your architecture, including your legacy parts, how many dependencies are on the execution path? Because the number of dependencies is the answer to these questions. These are the number of possible vulnerabilities over time, including the legacy parts. So it's quite easy to just take a look at the cloud native part as such, but to be honest, well, it's not a holistic view. Because over here we got a short sample. Yeah, we got a little infrastructure containing of a legacy server. You can take any kind of JEE container, for example, WebSphere, NetWeaver, you all know them. And this legacy server is going to receive this request, and then this legacy server is going to make some workload, and then it's going to execute a workload in a pod. This pod is going to handle the workload from the legacy server, and it's going to execute a second pod. Yeah. So this is just a classical, very, very small overview. So if you take a look at the execution path, we have now several paths where we have dependencies. First of all, we got the application over here, which can be handled similar to the application in the pod. Plus, we got a legacy application server, like in the best case, it's the Tomcat. In the worst case, it's some much, much bigger JEE container, for example. Plus, we got all OS packages over here. Yeah? Plus, we got the application over here, plus the OS packages in the container, plus the application over here, plus the OS packages in the container. So it's quite a lot. It's quite a lot of different dependencies in this heterogeneous environment. Okay. So scanning at build time is not really working because, first of all, vulnerabilities can occur after build time. That's the first thing. And to be honest, a very small amount of people voluntarily want to touch that one. Yeah. I guess it's like, okay, it's stable, it runs, it's in the rundown somehow in the next 2 till 4 years anyhow. So we do not want to, or very, very rarely want to touch that one. So how can we get any kind of transparency in this architecture? Well, we all know that there are several possibilities to get transparency in our architecture. The first possibility to get transparency is we can use tracing. Yeah? Jaeger, Zipkin, you name it. And tracing cares about the requests themselves. So we can trace, for example, the request to the legacy server, and in the best case, well, for sure we can trace the request in the Kubernetes cluster itself. In the legacy world, it can be hard to adapt. Why? Well, as I said, we do not really want to touch that one. Yeah? We do not really want to touch the application itself, neither the application server, or, well, at least if we have to, the operating systems because of some patches coming along. So, nevertheless, tracing helps me to get any kind of transparency. The second aspect, which is going to help me to get transparency, is dependency management. So now we got this SBOMs, and from my point of view, we are now in the position within the last 1, 2, 3 years, since Log4Shell, to be honest, to handle SBOMs quite efficiently. Yeah? So that means over here, we are going to generate the SBOMs for our images, for our containers. We are going to store them near to our artifacts and so on. But related to the legacy world, I also face the same problem. What possibilities do I have to generate knowledge about the dependencies running on the legacy server, and how can I handle these kinds of dependency management over there? So the overall question is, what possibility do I have to get an overall knowledge and holistic view about the tracing plus the SBOMs in this heterogeneous environment? And the solution we are going to present, or Esra is just going to show this in a couple of seconds, is well, we are just using the well-established toolset in the cloud world. That's not really very brand new. Many of us are doing this. Plus, we are going to inject some traces based on ePPF, based on Cilium, well, actually based on Hubble, directly to some collector. And we are going to enrich those traces with SBOMs, which are generated on this on this instance. Okay. So I need two things. I need SBOMs and I need traces. SBOMs, common cloud native artifact, is trivial. We all know this comic from XKCD, from this small guy, from this guy in Nevada who is going to handle that one. And this one is as I said, it's handled at build time. It includes the application. It includes all kind of packages in the image itself. It's without any kind of problem. I can generate this stuff either at build time or with some tools like Sift and so on. Related to the monolith, things are a little bit different. Well, first of all, I got the application, which is handled by some dev team. Plus, I have this ops stuff, because in most cases, this monolith is operated manually. This is classical pet stuff. So that means I need to gain some knowledge over here. And to be honest, this is possible with tools like Sift as well. It's possible to generate SBOM information about the stack. It costs some time. It's not really efficient. You really have to know where to scan, stuff like that. But you can do it in a scheduled way. Plus, you are able to store the SBOM somewhere near the machine or in an artifact repository. So you got a holistic overview about all software over here. So the second step is the trace generation. I'm going to be quite quick over here because this is trivial. I can either get some trace information about the implementation in the implementation itself if I use it. I can use some open telemetry, auto instrumentation. This is working as well. I can use some sidecar. So all of these measures work without any problems, and I can just push the traces to a collector. But what about the old world? Well, in the old world, I can use eBPF, Cilium, Hubble to get knowledge about the network connectivity, about the network connections, and I can generate the traces based off them and push them to the same collector as well, enriched with some SBOM generation. So I hand over to Eska because he will show you now the implementation plus more.
Thank you, Sebastian, for the instructions, for the introduction. Let's have a look at our solution approach. As Sebastian already mentioned, we have a Cilium network as the base. And we don't only use it as the CNI for our Kubernetes cluster. We add the external workloads as external, we add the hosts as external workloads to the Cilium network itself. That's the base for our application. There from Cilium, we use the Hubble socket to get network events into our agent. Our agent is the heart of our solution. It generates, on one side, the SBOMs, and on the other side, it analyzes these events we get from Hubble. If we generate an SBOM, we push that SBOM to a harbor, an OCI registry, and on the other hand, we push the events or the messages to a NUTS queue, where the other component of our solution is listening the server part. And the server analyzes those messages and generates the traces, which are visualized in Jaeger. Now let's have a look at the request itself. Here we have a request from outside, which triggers a service on the legacy host, which makes a request to the Kubernetes cluster, and we now want to analyze this request. So thanks to Hubble, we get information about this request, either on the legacy part and on the part of inside the Kubernetes cluster. We have to deploy our agent on every node of the Kubernetes cluster, and we have to have running the agent on every external workload. So, but thanks to Cilium, we don't have a boundary between the legacy world and the Kubernetes world. Yeah, that we already have. We are the network event, and after we've received the network event, we get that into the agent, and there we run some analyzation. We first filter it if we're really interested in this event, and afterwards we check if we already have this event, because sometimes we get a lot of events if the application is really busy, so we don't want to make the analyzation for every request. If we make an analyzation, we run some modules of that on that request. We, for example, get the image of the workload inside the Kubernetes cluster, or the digest of the image, and we publish this to a NUTS queue. And there, after that, we receive that on the server side. Now, okay, we have the events on the server, but what about the SBOMs? Well, we generate the SBOMs in intervals. We make a distinction between the SBOMs generated for images and the SBOM generated for a legacy host. Because if we are on the Kubernetes cluster, we want to analyze the images, and as Sebastian said, on the legacy host, we want to analyze the file system. Okay, what happens? Well, we ask the container runtime to get a list of our images from the container running on that node. After we got that list, we get the images from the container runtime, and we check either if there already exists one from the image provider, or if we already created one for that digest. If that's not the case, we create that SBOM with Sift over there, and we push that SBOM to Harbor. And of course, we publish that event to our NUTS queue. On the other hand, on the legacy hosts, or on the host system, we have also these intervals, but we have to take longer intervals, because if we have a big host with maybe 100 gigabytes of data, it takes a lot of time to scan those hosts. So we do that in longer intervals than for the images, because on the images, we can easily decide based on the digest if we have to analyze it again or not. And of course, we push that to the NUTS queue again. Well, that's it for the agent part. What happens on the server? There we have 3 different threads in parallel. The first thread is to receive the network event. We receive these messages. We evaluate the network event. We will have a look at the source and the target of the network event, and we keep that in memory for the further analyzation. We talk in a few seconds. Then we have the thread where we receive the SBOM messages. We save that also in memory to get a match between the identity of the workload where the SBOM is coming from and the URL to the SBOM. And of course, the most important thread in this part is the part to build the trace itself. For that, we analyze the network event we saved in memory. We enrich these messages with the SBOM URL based on the identity, and we make that publish that to Jaeger. Now, what happens next? We have now our traces, we have our SBOM URLs. Now we want to do a security scan. For that, we get the trace ID from Jaeger. We pass that trace ID to our tool. And now, because we enrich that with the SBOM URLs, we know for each of these span exactly which SBOM belongs to it. So we can get that SBOM, as you can see here, an example of a small example for, I think it's JUnit in this case, this dependency, but doesn't matter. And we can take this SBOM and scan, for example, with Graf. We can loop over the SBOMs and generate and get the vulnerabilities out of that trace. Of course, now we get a big list of vulnerabilities, and we have to manage that somehow. That would be a next step in our project, that we can integrate automated actions. But of course, if you enable automated action and you separate your vulnerable workload from the rest, you have a service disruption. So you probably don't want that. But now I've talked enough. Let's move to the interesting part of our talk, of course, a demo. Okay. Here we have the nodes. You see we have 3 nodes. I can maybe show that. Here we have a master node and we have 2 worker nodes. Just a simple setup. Now we get a list of the pods which are part of our solution. As you can see, we have 3 agents running, 1 for every node in our Kubernetes cluster, and we have the server running. Now that's the part where we add the external workload to our Cilium network. We can see this as a custom resource in our Kubernetes cluster. We can here see the IP of that workload, this one. Yeah, and that is part of our cluster. Now let's make a request from one server outside this our setup to a legacy host. And then we have a request inside the Kubernetes cluster, and we have a simple. Sorry, I was a little bit fast. I have just first here you can see the pods on the external workload. As you can see, we have here the agent running. We have an Nginx as our application on that host, and we have Cilium. This is part of the external that we can run the external workload. We have this Cilium pod here. Now let's do the request. Yeah, it's just a simple request. We get over the Nginx and then inside the Kubernetes cluster. And now this generated a trace. We have one looked up before. Now we can see here we have the external workload. I'm sorry, I just have to. Oh, here, this one. Maybe maybe you can see a little bit better. And as you can see, we now have here an URL to our SBOM. And the same. Here we have our application. And the application itself also have a request to this application child. And as we can see here, we always should have this SBOM somewhere. Or maybe I've just have taken one. Yeah, I was too fast by collecting this. Maybe we can just take another one. Now we should have. The SBOM wasn't generated at this point in time where I took this example. Now we should have. Yeah, now we have the SBOM, as you can see here. Okay. Now move on. We'll run an analysis against this trace. I've put the trace ID into an environment variable before, so I don't have to copy that. Now you can see it makes this analysis, and you can see for every, we can scroll afterwards. Yeah, as you saw maybe before, there was also the Harbor part. Of course, we have from our tool itself requests to Harbor, so we analyze the whole Harbor part too, because there's a dependency between them. So we have there a lot of dependencies here and a lot of vulnerabilities, as you can see. Yeah, we can just scroll up here a little bit. You see, this tool isn't, yeah. We have some critical, we have some high, yeah. Now I just have a look at these SBOMs. We just pull one of these SBOMs from our OCI registry with Crane. And we save that to our, that's the image itself. Now we are just interested in this layer here. We get that layer. That's the effective SHA from that. We just extract it. Now we can download this layer itself. As you can see here, that's the SBOM of this external workload. I've here for it's because it takes a lot of time to generate the SBOM. We just have a subfolder taken for the analysis. As you can see, we just have here a lot of dependencies in this subfolder. And now we can just analyze this SBOM itself, which works too. Yeah. And of course, we can have a look. We see this SBOM here in Harbor itself. You can see it's uploaded here. That's where we got the SBOM from. So that's the demo. I think we are a little bit fast, maybe.
More time for questions.
More time for questions, exactly. So let's go back to the Sebastian.
Yeah, we are nearly done. As you showed you, we got this use case of tracing vulnerabilities between a legacy world, or with a holistic view on the legacy world as well as in the cloud native world. And yeah, we are having, on the one hand, we are having this vulnerability management, where we are using Graf for scanning. We are just giving the SBOM to Graf, and Graf is going to get a recent database of CVEs and just give us an output. Plus, we are using the SBOM generation. And over here, we are using in both worlds, in the cloud native world as well as in the legacy world, SIFT, in the legacy world in a scheduled base, in the cloud native world related to the build time or related to the request time, and upload this both to Harbor. So what we are trying to do, or what we actually, no, we are not trying to do, but we are doing it. We are just applying cloud native toolset also to the legacy world, which are not really invasive. Okay, you might say, come on, you have to deploy some CSIN agent. That's correct, but at least I do not have to handle in any kind the legacy application as well as the application server. Because we are using for observing Cilium, we have to deploy a Cilium agent directly on the legacy host. But doing so enables us to push any kind of traces to the same tracing approach that we are also using in the same context in the cloud native world. So what you saw so far is open source. It's mainly the CSIN agent, so we are not pushing any kind of Harbor setups, stuff like that. But the CSIN tile is open source. You can just check it out. It's, as you said, it's not production ready. It's a kind of a proof of concept. We will see how we will further develop this approach. But nevertheless, it enables us to get some kind of knowledge in a holistic way. So we are done. If you have any questions, hopefully we can answer them.
Thank you very much, Sebastian and Ezra. So, questions? Let me quickly get both hands here.
Oh, jetzt geht's.
First, thank you for your talk, because in our company we have this problem with all the legacy applications and slowly moving over to Kubernetes, and tracing and finding vulnerabilities is a big issue, because like no one has the full overview over all the setups. What I wanted to ask, if you have any method or so, because finding vulnerabilities is one thing and then dealing with them is another. Mm-hmm. And often, or I had it sometimes, that there were things found and then deemed that we won't fix it, or that it's really not an issue because it's not exploitable in this way, and that you don't always like find the same CVEs again and again and again, where you said like here before, we won't fix it because we don't have to. So have you anything how you manage these findings?
I think that would be a further work. We could, for example, add some Ausnahmen, some exceptions for some workloads. We could manage that as Kubernetes resources, for example. So we can say for this request, for this service, we not interested in this CVE. As I mentioned before, we could add some automation to that to block some traffic, maybe with Cilium network policies. That would just an idea how we could handle that in the future.
Thank you.
Further questions? There was one. Florian.
Yeah, actually, I have a similar question. So there is the term CV shock, and as you've shown, for sure you will have high critical vulnerabilities on the path. Now the question, how do we tackle them, or who is tackling them, and how do we boil down this huge list to something actionable?
I think that would be also a question of the setup. If we could implement some stuff, if we say we just need a certain score to do something and then do a service disruption and take the service out of the whole concept. Of course, we have then a service disruption, yeah. But that's the price, I think. If we have such a high CVE that we have to take down the service, That's the price you have to pay, if you will.
I would like to extend this. It's also a question on which layer the CVE happens. So if you're on the dev layer, obviously in the legacy world, other people are responsible than handling it on the ops layer. That's one thing. And the second thing is, this is actually just finding out the points. What is needed one step further is depending on the organization structure itself. So I made very, very good, let's call it, experiences when you're just filing automatically tickets. So you're getting knowledge about the stack, and then you're just pushing it to some scheduled task and make tickets and just assign them to the right persons, make work in a fully transparent way that people are aware of it and that other people are also aware of it. Because as you saw, this execution path is not only handling one application, in most cases it's handling entire architectures.
There's one over there.
First, thanks for the presentation. I was wondering how you guys deal with kind of false positives and whether there is some scoping for the legacy system, because you mentioned it, right? Legacy, it's wild, and you make quite deep and bright scan because you go from file system and you go all way around. So can I basically indicate, or is there some configs how you guys deal with that? Is it scope to application, or it's a bit more broad and I will get really a lot of false positives, which my experience with SBOMs and tooling, it's then when you get a lot of information, basically you try to ignore it, right? Because it's a lot and you just, oh, it's just all minor. And so how do you deal with the importance of things and on the relevance, basically?
Should I?
You can.
Okay. I guess this question has two aspects. The first one is the aspect of the black whitelisting of known issues, and I guess with this aspect you really can filter most of the issues out of the way. Of course you have to do it once, and you should do it as I said, in a transparent way, but then they are done. And the second issue is, I guess, we made some analysis about that we are going to analyze only dependencies on the process itself on the legacy system. We really tried it hard. It was not really possible, to be honest. So what we did actually was, at the moment, we are really analyzing the entire system. That being said, the kind of analyze depends on the path you are giving to the SBOM generator. So you have the ability to somehow can choose which parts of the operating system and the application servers and stuff like that you are going to put in your SBOM. So it's up to you. But as I said, it's a combination of both. First, you have to find out the right path. Second, you have to whitelist it. Working on process space was not working.
Yep, thanks.
Any further questions? Others, Philip?
You mentioned that this is obviously not production ready yet and more of a POC. If this ever was to get into a proper V1 and becoming production ready, if people wanted to really push forward on this, what do you think would it take? Is it just in terms of hardening, making sure that everything is as stable as possible, or do you see that there is certain features still lacking for that specific approach?
I would like to return the question. When is the software production ready?
Well, according to that, we shouldn't use any software in production.
So no, at the moment, I think this project is a very cool. Well, we proved it practically, so it's working, yeah, and it has no failures. As you saw, the pods are running quite for a long time. But as I said, we did not make any load testing. We made some functional testing. We did not really make non-functional testing, stuff like that. So I guess one area would be to extend the tests. That's one thing. The second thing is to introduce a measurement measures for whitelisting, blacklisting stuff, for getting rid of all the false positives and all the things where you know that they are there, but you can voluntarily ignore them. I guess those are the biggest points at the moment we are aware of. The rest to find out is up to you guys and girls.
Amazing. Thank you.
We still have time for questions if anyone has more. Patrick over there. Incomplete pass.
Yeah, I was going to ask, so if I understood correctly, you're scanning the images at runtime, right?
Yeah, we get the images from the container runtime, so we don't have to download them again to just analyze them. We take them from the runtime because they're already present on the node.
Yeah, my question was going to be basically then, why not generate the SBOM at build time? Because it is possible with BuildKit to generate the SBOM and bundle it directly in the image.
Yeah, you could do that, but if you use external images, for example, not everybody does create the SBOMs for you. So you have to deal somehow with that.
Actually, when you took a look at the diagram, you saw that that we are checking whether an SBOM is existing or not in the registry, and if it's existing, we are consuming the existing SBOM in the registry. So if there is an SBOM also deployed within the image, we are fine with it. If not, we have to regenerate it.
Right. There's another one by Florian.
So you opened up with your answer a new question. So when you get the SBOM from the registry, how do you check the confidentiality and integrity of this SBOM?
Good question. We thought about that. I think there's not that you can get the public key somewhere. It's not everywhere the same place you get the public key from. So it depends on the product. If you can download it from the website, and then maybe you can analyze with SIX stuff. You can analyze if you have the correct SBOM, but it's not. You don't have the same way to get these keys for every product. So we can't implement a general way to get those keys.